Download this code from codegive.com, link in the description below. Tutorial: Understanding the Data Access Layer, DAL. The Data Access Layer, DAL, is a crucial part of application architecture, serving as an intermediary between the application's business logic and the database. The DAL abstracts the details of the database interactions, providing a clean API for the rest of the application to work with. Key concepts: 1. Separation of concerns. The DAL separates database logic from business logic, making code easier to maintain and test. 2. Encapsulation. The DAL encapsulates the database interaction details, so changes to the database, like switching from SQL Server to PostgresQL, require minimal changes in the application. 3. Reusability. Common data access logic can be reused across different parts of the application. Components of a data access layer. 1. Database connection, responsible for establishing connections to the database. 2. CRUD operations, functions to create, read, update, and delete data. 3. Data models, classes or structures that represent the data in the application. Example implementation. We'll create a simple DAL in Python using SQLite as our database. This example will illustrate common CRUD operations for a user entity. Step 1. Setting up the environment. Make sure you have SQLite 3 installed. This is included in Python's standard library, so no additional installations are needed. Step 2. Create the database and table. Python. Import SQLite 3. Def initialize _db. Con equals SQLite3.connect, example.db. Cursor equals con.cursor. Create users table. Cursor.execute. Create table if not exists users. ID integer primary key auto increment. Username text not null. Email text not null. Con.commit. Con.close. Initialize _db. Step 3. Create the data access layer. Here we'll create a simple user DAL class to handle all interactions with the users table. Python. Class user DAL. Def _init_self, db _name equals example.db. Self.db _name equals db _name. Def _connect, self. Return SQLite3.connect, self.db _name. Def create _user, self, username, email. Con equals self _connect. Cursor equals con.cursor. Cursor.execute, insert into users, username, email, values, username, email. Con.commit. Con.close. Def get _user, self, user _id. Con equals self _connect. Cursor equals con.cursor. Cursor.execute, select asterisk from users where id equals, user _id. User equals cursor.fetchOwn. Con.close. Return user. Def update _user, self, user _id, username, email. Con equals self _connect. Cursor equals con.cursor. Cursor.execute, update users set username equals, email equals. Where id equals, username, email, user _id. Con.commit. Con.close. Def delete _user, self, user _id. Con equals self _connect. Cursor equals con.cursor. Cursor.execute, delete from users where id equals, user _id. Con.commit. Con.close. Def get all _users, self. Con equals self underscore connect. Cursor equals con.cursor. Cursor.execute, select asterisk from users. Users equals cursor.fetch all. Con.close. Return users. Step 4, using the data access layer. Now that we have our user DAL class, let's see how we can use it in our application. Python. Def main. User underscore DAL equals user DAL. Create users. User underscore DAL dot create underscore user, John underscore Doe, John at example.com. User underscore DAL dot create underscore user, Jane underscore Doe, Jane at example.com. Read user. User equals user underscore DAL dot get underscore user, 1. Print, f user 1, user. Update user. User underscore DAL dot update underscore user, 1, Johnny underscore Doe, Johnny at example.com. Updated underscore user equals user underscore DAL dot get underscore user, 1. Print, f updated user 1, updated underscore user. Get all users. All underscore users equals user underscore DAL dot get underscore all underscore users. Print, all users, all underscore users. Delete user. User underscore DAL dot delete underscore user, 2. Print, all users after deletion, user underscore DAL dot get underscore all underscore users. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. Main. Summary. In this tutorial, we explored the concept of a data access layer, DAL, and created a simple implementation in Python using SQLite. The DAL provided a clean interface for interacting with the database, encapsulating the logic for CRUD operations. Benefits of using a DAL. Maintainability. Changes to the database schema can be managed within the DAL without affecting other parts of the application. Testability. The separation allows for easier unit testing of business logic without needing to interact with the database. Flexibility. Switching databases or changing the data source can be done with minimal changes to the application. Using a DAL is considered a best practice in software development, especially for applications that require consistent and reliable data management.